So it's still 8 if that's the last energy level there. But if there's another energy level outside of it, I can put 18 in there. Does that make sense? All right. Fourth energy level. Fourth energy level. All right, gets even funkier here.
Wait, come out.
All right.
So, okay. Why is there a fourth energy level?
Well, this is 1, 2, 3. Get up to 4 now. Actually, there are 7 of them.
So why not just keep the third one 8 and then just do the fourth level 18?
Because that's not the way they actually work. That's what that's the way you learned it in physical science. But now we're in chemistry. We're going to step it up a bit, right? We're going to learn a little more. Because, you got the physical science stuff as a foundation. We're going to add on to the foundation. We're going to build on that foundation. Make the building higher. Okay? Build on your knowledge. All right, so the fourth electron energy level. All right, in the fourth energy level, 8 electrons is the maximum number of electrons if that is the outermost level. Okay. 18 electrons is the max if the fourth energy if the fourth level is the next to last and 32 electrons if it is or let's say it has 2 or more levels above it. So we're getting kind of complex here, aren't we? Okay? Getting a little bit harder and harder to keep up with all this. So we need a way of kind of making sense out of it. And that's what we're going to be doing in this unit. So, fourth level.
This is the last one we're going
That's what we're going to talk about here. Because after the fourth level, all the others that follow it behave the same way. Okay, the fifth and sixth and seventh levels all behave the same way. Okay? Got that? Yeah, I can wait a second. Sure. Yes.
Did you ever have a mullet?
Did I have a mullet?
Did you have
The haircut?
Yeah.
No, there's a fish, the mullet, right?
No.
You know that? I love mullet, the fish, but no, I never had a mullet haircut, no.
Did you ever have a Jerry curl?
A what?
A Jerry curl?
I never tried to have a Jerry curl. When I was in junior high school, I actually had a curl that sometimes did that, but that was only because it just happened.
Oh. What does this have to do with physical science?
Not a thing. Not a thing. I don't know why she's asking. She's completely off into some other class somewhere, in some other building maybe. I don't know. Oh, okay. So she's taking cosmetology at RD. Is that the deal?
Oh, no.
Oh, all right.
I just want to know. You just look like you had a mullet.
Like I had a mullet? Why would you say that?
Because you look like you had a mullet.
Where do you get that from? How? No, I had long hair and I had a beard, but I didn't have a mullet. All right. Now, so we've talked about 32, yes. 32 is the maximum. if it has 2 or more levels above it. Okay? Alright, so back to our demonstration with our green flame over here. We said that was boron in there. Okay? Who is boron named for? Bor. Okay? Well, boron over there glows green because the electrons are being excited by the heat energy. Okay? And they're jumping levels. They're jumping up levels, and when they fall, and the reason they jump up levels is they're absorbing energy. Anybody play a piano? Who plays the piano? Raise your hand. All right, good. Have you ever opened the top of a piano and plucked one string, and then put your finger on that one string?
On a piano?
Yes. And what happens when you do that? Huh? We try this. Listen, try this sometime. Open a piano and pluck somewhere in the middle. It's easier to hear it in the middle. And just you got in the middle. You've got 3 strings that are all the same note. Okay. Just pluck one of those 3 strings, and then take your finger and put only on that string and stop it from vibrating. You'll hear.
Yeah.
Well, no, I'm talking about a piano, but it works on a guitar too. I'll talk about that in a minute. Okay. If you pluck that string and then dampen that string, you'll hear those other 2 strings on that same note that'll continue to vibrate. You can hear the note from those other 2 strings. Now, it's also, if you dampen all 3 of those strings, you'll still hear a note in there if you really, really listen. Because those 3 strings right there are causing other strings that aren't even on the same note to vibrate. Okay? And that's what happens with the guitar. With a guitar, you can pluck one string, and if you have another string near it that happens to be on a 3rd above it or a 5th above it, how many of you know what a 3rd or a 5th means? No? You do. Okay. So a 3rd or a 5th, you'll hear those other strings vibrate if you dampen it and listen really, really carefully. Okay? Because because the vibrations all kind of let's see, they affect each other. All right, I don't want to get too complex here. Well, what happens here is these electrons can jump 1 level or 2 levels or 3 levels, and they can fall back down 1 level, 2 levels, or 3 levels. Okay? And one of those level jumps, and actually there's sub-levels within there too, gives us that green color over here you see in the flame. So when it falls back down, it's absorbing energy from the heat, and it falls back down and it gives off photons. Now photons are little packets of light. How many of you ever heard the term photon before? Anybody here a Star Trek fan? You are? So what's a photon torpedo? Well, now you're not a Star Trek fan if you don't know what a photon torpedo is. Okay. So how many know what a laser is? All right. A laser is simply light of all exactly the same wavelength. That's what a laser is. Okay. The scientist who first invented that whole process, he didn't invent a laser. He invented something called a maser, which is like a laser, only a laser is visible light, a maser is microwave light. Okay? And he lived in Greenville. He grew up in Greenville, went to Furman University. The science building over there is named after him. And there's a display of his work and him in the State Science Museum. Okay? So just so you know, there's a little tie in here locally. All right? So they took that whole process and made all that work to make something called now called a laser. All right, so now we're going to talk about some things in the electron cloud here. Okay, we're going to do the electron cloud. And so what do we find in the electron cloud? Electrons. That's all that's there. And most of it's space, and we talked about how big that space is. Okay, so the electron cloud is all electrons, and they are located around the nucleus. All right. And then electrons themselves they have a what kind of charge? Negative charge. Wow, you guys are doing great. Somebody did a really good job with you in physical science. All right, a negative charge. how about their mass? Actually, there's no such thing as negative mass. Okay. Virtually zero. Let me explain what I mean by that. Virtually zero. What are you guys breathing right now? What kind of? Actually, we're breathing all kinds of gases. Oxygen just happens to be the second most abundant. The most abundant gas in our atmosphere is nitrogen. So you're breathing in gases. And what's the mass of gases? Well, it's by comparison to solid stuff like this desktop or your desktop or the floor you're standing on, their mass is much, much smaller per unit of volume. Okay? But now, in addition to the gases you're breathing in, there's dust in the air. So you're breathing in some dust. And gross as it may sound, you're actually breathing in some dead bugs too. How many of you ever noticed in a sunbeam shining through the window, there are little specks of light in there? You ever notice that? That's those little dust specks and little dead bug specks and things like that that are reflecting that light. Okay? Now, how much do those little specks weigh? Could you weigh it on a balance?
No.
You couldn't even get it to move, could you? Not with one of those on there. Well, the mass of an electron is so small compared to that of a proton and a neutron, we kind of ignore it. It actually weighs something in the order of 2,000 times smaller. Okay? So we kind of ignore it. Okay? So we're going to say, even though it's not true, because it is so small and we can just about ignore it, we're going to say that its mass is 0. Okay? 0 U. And we could say it's 0.00028 U. Okay? But, I mean, it's just like we can ignore that. It's so small. Okay? Got it? All right. It has a negative charge then. It has a mass of U, and its symbol, and because Jamila didn't like the dash I put on there earlier, we're going to put an arrow and say it's an E with a negative, sort of superscript negative, okay? Superscript negative. Your way of the highway. Well, no, I don't know about that. You know, I try to give you what you need, right? I try to. All right, now, this is, for right, we're going to come back to the structure of the atom or the electron cloud, and we're going to learn about some of the things of the nucleus, some of the electron cloud later. We'll kind of leave this off for a minute. We're going to go to periodic, the arrangement of the periodic table first. But before I leave that, just before I leave that, I want to leave you with this information, okay? Because inside these primary energy levels, these electron energy levels, there are other energy levels. They're called sublevels. So inside these electron energy levels, these primary energy levels, there are sublevels and something called orbitals. Orbitals.